All right, if you guys would like to be walked through this, I am so excited. I know that it's the end of the school year. I know they have a lot of other stuff going on and you might be mad at me for assigning you things, but ASA, SAS, and SSS are very important. And again, geometry is what you're going to start with next year. So I just wanted you to do the first 4 pages today, and I'm hoping you could do them on your own without this, but I'll just walk you through it anyway, in case you think you need. So, reasoning. This is actually very cool. A lot of math people, like in high school, you don't really learn this. So a lot of math people consider this like true and real math, which is just like, is something true? Like, there's a hypothesis and a conclusion. Like, if this is true, then this must be true. And that's the basis of math. So your quick little review here, I wanted to make sure you know what these things are. A linear pair of angles. A linear pair of 2 angles is linear, comes from the word line. So you're going to draw a line. And then if this line is split, so let's say I have a ray that comes out like this. You've now created a pair of angles. You have one obtuse and one acute angle. This is a linear pair, and that's it. So if you'd like to name them with some letters, you can put some points with some letters, but this is sufficient. Number 2 has specific letters, so it calls a line AB. So I'm going to draw a line segment with end points A and B, and then you're just supposed to draw point C that's on it. So this one is supposed to have letters, and it does not matter where C is because it just says it's on the line, doesn't matter where. And then finally, number 3, point D is a point on the interior of angle ABC. So we need to make an angle. It can be as big or as small as you want. This symbol is an acute angle, but maybe I'm going to make an obtuse angle. So I'm going to make my angle have a vertex right here, so it looks pretty wide open. And if this is called angle ABC, maybe A to B to C is going to be where I draw it, or A to B to C. So I'll say maybe this is A, B, C. So ABC creates this large angle that is obtuse. And if it says that point D is on the interior, we're going to say that point D is somewhere inside this angle. Oh, whoa, that's supposed to be a D. Is somewhere inside that angle. And that's all. So quick geometry terms, make sure you have letters when you need them. You know what angles are versus lines. They have different symbols that we're going to read. And on the next page is where the cool sentence stuff starts. So, getting started. I would like you guys to talk to your neighbors. I'm not going to give you the answers. Is this true or false? Are all rectangles quadrilaterals? Are all rectangles squares? And then, if it rains today, then it will not rain tomorrow. Is that true or false? So pause the video and do that really quickly. When you come back to the video, I have activity 1 for you. So it says, you've used different kinds of reasoning to arrive at conclusions and to justify those conclusions. For example, if you are in Miss Roberts' class, then you must be a freshman. Is that true? No, of course it's not true. I have several students in Math 1 and Math 2 who are not freshmen. So this reasoning is used in formal mathematics, which is exciting and cool. We have to be able to identify when conclusions are false. So there are 2 reasons conclusions could be false. Either the assumed information is false, or the conclusion does not necessarily follow from the hypothesis. So consider each statement. You can answer these on your own. Is this true? Is this false? Is this true? Is this false? And then it says, write an example of a conclusion that is false because the assumed information is false. So what if we said, if the assumed information is false would be like, if something, and then that something is false. So if whales could fly, then they would have wings, or whatever. Because in this case, it doesn't matter what comes next. That's not true. Whales can't fly. then they would blah, blah, blah. It doesn't matter because the assumed information is false. Here is a conclusion that's false because the argument is not valid. So this example is a little bit harder. Let's see if you can come up with an example on your own. So maybe you'd say, if today is the 31st, which it's close to the 31st, then it is either July or August. Now, if today is the 31st, it could be July because July has 31 days. August also has 31 days. So it could be July or August, but the way that I've written it, the argument is not valid because if today is the 31st, then it is July or August or January or December. Like there's more choices. So this is just not true. It's an invalid argument because of the way that I stated it. And then the next page is the last page that I needed you to do for today. I'd like you to do more, of course. Can you provide a counterexample? So counterexamples are very important. For the last example I just gave, I had counterexamples. My counterexample to this was, well, it could be January. That's a counterexample. It could be December. Those are just two instances where that is not true. So you just need to come up with an instance that makes the statement not true, and then it's a false statement. So all prime numbers are odd. If you look up a list of prime numbers, you will find that most of them are odd. So first thing, do you think this is true or false? Well, if you look up a list, the answer is false. And the only reason it's false is because there is one counterexample. There is one number that is prime, but not odd. So when it says all prime numbers are odd, yeah, most of them are. 3 is, 5 is, 7 is, 11 is. But the only one that isn't is 2 is prime. But is 2 odd? No. That's your only counterexample you need. You've just proved that's a false statement. The sum of the measures of two acute angles is always greater than 90 degrees. Can you guys think of two acute angles whose measures don't add up to something greater than 90? I think that you can. Here's two acute angles. I'll say this is like 10 degrees and this is like 20 degrees. I shouldn't be doing this for you. But if you add up 10 and 20, is that greater than 90? No, they add up to 30. So the way you would write this as a mathematician, you would say, here are two acute angles, because they are, by definition, they are acute because they're less than 90. Here are two acute angles, so the premise is true, but they're angles whose measures add to 30 degrees. And 30 degrees is not greater than 90. So we've proved that it's not true, which is very cool. Okay, so I'm actually gonna end up skipping a lot of this for you guys. This is fun. So I know I told you to end here, but we call these statements conditional statements, and they're if P, then Q. We always use the letters P and Q, and there's a fun symbol for it. So if P is true, therefore Q is true. We can also read this as P implies Q. So if P, then Q is a statement. So if today is Wednesday, then tomorrow is Thursday. That's a true statement. The truth value means either it's true or it's false. If this is true, then that is true. We call this the hypothesis and this the conclusion. And so you guys are going to be proving some very specific math facts, and we're going to skip a lot of this, but it's cool. I mean, if the measure of an angle is 32 degrees, then it is acute. That's true. If the measure of an angle is not 30 degrees, the angle could still be acute, etc., etc., etc. And then we're gonna focus on, maybe I'll have you guys do some of this assignment page. And yeah, you should start doing this assignment page maybe also. So if 1 and 2 are vertical angles, then 1 is congruent to 2. You might not know what vertical angles are, so I guess I couldn't have you necessarily do this A, but you could do B. If measure of angle 1 is 100 degrees, if you have a 100-degree measure, is it obtuse? Yes. Okay. The real focus is going to be on ASA, SAS, and SSS. This is probably going to be on the final exam. Just a little bit of it, but still. Last stuff for this semester. Congratulations on finishing. I'll see you next week and tomorrow for this work.